about graphs of position versus time. By the time you're done here, you should be able to interpret position versus time graphs and create them as well. So a couple of things I really want you to remember. One is, do not try to memorize all the variations of these particular types of graphs. Look for patterns, right? But don't make assumptions. And also be sure to actually read what the graph is showing. We're going to go over all of that now. So you're going to look at the axes. You're going to verify what the variables on the axes mean and what units they're in. You're going to use the slope formula to see if the slope has a physics meaning. If so, we're going to overtly show this. So when we look at the slope, don't forget it's delta y over delta x. That's y2 minus y1, x2 minus x1. So you always need two coordinates off of your best fit or off your trend line. So let's go through an example. Here is position versus time graph. On the x-axis we have time. On the y-axis we have the x position, which means it's moving horizontally. The graph itself is a straight but diagonal line. What do the axes say? Make sure we know what that means. Position is where the object is located relative to the origin. And then we're going to look at this line and be like, oh, this is a trend line. It is a diagonal line. It has a slope. I know slope is delta y over delta x. And since this is a position versus time graph, the slope must be delta x over delta t. That's velocity, right? The definition of velocity is the change in position over the change in time. So the slope is the velocity. You want to overtly state these things. So since the slope is the velocity, I can now look at this and be like, oh, it has a constant slope. Therefore, it has a constant velocity. It has a positive slope, so it has to have a positive velocity. Positive velocity means it's moving away from the origin or forwards. Those are the pieces of information that you can get just by looking at this very simple graph. Take a look at this graph and fill in the blanks in these steps. So look at the axes as step one. Make sure you know what those mean. So what do these variables mean? What does x mean and what does t mean? Then, what does the slope mean? What is the formula for the slope as it's applied to this? I know this is a curve, and therefore you might think curves don't have a slope because they're not a linear fit. However, each piece of this has a slope. So there's a slope at the beginning, there's a slope in the middle, there's a slope at every point. You could make a tangent line and get a slope. The slope still has a meaning that's useful to you. So let's go through and answer this. The axes are position and time. Position is where the object is located relative to the origin. And since the slope of this graph is delta x over delta t, and velocity is defined as delta x over delta t, the slope is the velocity. So when I interpret this position versus time graph, I can say the position is getting smaller as the time gets bigger. Therefore, it's moving towards the origin or backwards. And then the slope is increasing, therefore velocity is increasing. If you look here, we can look at that again. So here you start with a big position and you end close to zero. That means your position is decreasing, so you're moving back towards the origin. We call that moving backwards. Also, look at the slope. If you were to draw a slope here, it would be horizontal. That's zero slope. Zero slope means zero speed, so you're really not moving up here. Then when you get down here, all of a sudden, you've got this really, really steep slope. You must be moving really fast. So you're moving really fast with a negative slope. Therefore, you must be moving in the negative direction with increasing speed. You can draw a position versus time graph of any type of motion. For a position versus time graph, remember, the slope means velocity. If you look at this one, your position remains the same the whole time. Whatever number this is, it's some number. We don't have numbers on our axes, and that's okay. But it's at rest because it's at whatever this position is. It stays there, it stays there, it stays there. Also, the slope is zero, and the slope is velocity. Therefore, the velocity must be zero. For constant speed, we have constant slope. For increasing speed, we have increasing slope. For decreasing speed, we have decreasing slope. Notice all of these in red here are in the positive direction. Positive slope means positive velocity. Now, if I'm moving towards the origin, right? If you're at rest, it doesn't matter. You're not moving, so you're just going to have a horizontal line. You're not going towards or away. You're just sitting there. When you're constant speed moving back to the origin, it means you have a negative slope, so you have to have a negative velocity. Here's another negative slope, but increasing. So it starts out almost horizontal, and then it gets steeper and steeper. So that's getting faster and faster, but in the negative direction. Here you're decreasing speed. You're moving in the negative direction, but your slope is getting less and less steep. A person is walking in a straight line to create this graph. Describe the motion that's depicted. So if I look here, right, I can see I start at the origin at 0 seconds. Then I move with this constant slope, which means constant speed, right? Then I've got this horizontal portion. That means I have no speed. I'm at rest because there's no slope. This portion, I'm moving with increasing speed because I have increasing slope. And I'm moving in the positive direction the entire time. Free fall has the same characteristics, except it's so specific. All free fall graphs look pretty much the same because when you're in free fall, you're slowing down on your way up and you're increasing speed on the way down. Those are the only two options. So if we throw something up, we've got to start with some speed greater than 0. We reach a maximum height where velocity is 0, so there's no slope. Then we move for the rest of the time with an increasing speed back down towards 0, towards the ground. This is what a projectile looks like if you throw it up and allow it to fall back down. If you just drop the ball, that means you start at some initial position where velocity is 0 because you're dropping it, and then you increase speed until you reach a maximum negative velocity at ground level.